out clouds of dust, turning day into night. The combination of the meteorite and the Indian volcanoes was too much. It turned the Earth's surface into a dark, burning world where all the rules governing survival of the fittest changed. The dinosaurs never had a chance. Those events 65 million years ago resulted in another dramatic turning point in the evolution of life.
The dinosaurs had all gone, most of the other reptiles had gone, and there was a void of large animals. Into that void, the mammals and the birds jumped very quickly. The mammals in particular have been held down by the reptiles, the dominance of the reptiles, for many millions of years. And they radiated out extensively all over the Earth. The primates emerged, and eventually we emerged ourselves.
The last leg of my journey through the story of life is here in Africa, not too far north of where I started with the origin of life. I'm in Kenya, in the Great Rift Valley of Africa. And it's here that scientists are discovering just how closely the evolution of the Earth is linked to the evolution of our own ancestors. Over the last million years, the Earth has experienced a succession of 10 glaciations interspersed with warm periods. This waxing and waning of the ice sheets has had a profound effect on the rest of the world's climate and our own evolution. Rick Potts spends every summer searching for evidence to show why modern humans evolved from our ape-like ancestors.
We're going up through time here, and then we reach a point where the soil disappears and this white sediment of the lake bed comes in, which shows that the lake had expanded and covered the whole area of the southern Kenya Rift just in this area. And again, these fluctuations continue, and then the soil comes back for just a short period of time.
What do you mean by a short period of time here?
Probably a few hundred years at most. And then the soil disappears and it's replaced by the lake up here. And then the soil comes back in again for a short period of time, lake again, and then a very sharp demarcation where the soil again goes as far as the eye can see. And this occurred at a time when the ice age fluctuations in Europe and North America were just really getting going, and tremendous fluctuations going on.
But how can rapid fluctuations between dry and wet periods be the driving force of the evolution of modern humans?
This is the species Homo habilis, and it had still a relatively small brain. This was a clever creature, make no doubt about it, but it wasn't quite us.
It reminds me very much of the chimpanzee. I mean, why didn't we stay as upright apes like chimpanzees?
Well, in my view, we evolved because of climate fluctuation, of the tremendous fluctuations and uncertainty of environments that we can see here in the geologic record. This is Homo sapiens, our own species. And this one evolved during those fantastic fluctuations of environment that we see beginning about 600 to 700,000 years ago. And you can see the incredibly large size of the brain case.
So the rate of change began to accelerate.
Yes, tremendous acceleration in the rate of brain growth. And this had to deal, I think, with flexibility, with the ability to adapt to those tremendous changes in environment. For example, communication. Through language, we are able to say, you know, my grandfather told me that the time before him that you could find fruits to eat on the other side of that mountain when there was a drought. And that's something that no other animal can do. Being able to refer to places and things and abstract things that you can't even see, and yet we can communicate about them. We're used to the idea that organisms are adapted through natural selection to match the specific environment in which they live. But I think there's another process of selection that represents an adaptation to the variability and the fluctuation of environments. And this is a process that distances an organism from any one specific environment. And I think that we, Homo sapiens, are the paramount example of this kind of species.
So we too, like the rest of life, are the product of constant physical changes that have occurred here on Earth. As a biologist, I've always concentrated on the evolution of life in biological terms. But it adds a completely new dimension to recognise how closely the evolution of life is linked with the inexorable changes of the Earth.
We now know that Earth isn't simply the place where we happen to live. We know it's a dynamic planet, and we know the Earth has been one of the driving forces shaping evolution since the very beginnings of life.
We also know that the way life has evolved on Earth makes our planet different from our neighbouring planets. But the Earth is also special in its geology. And in the next programme, we'll be exploring why we are so different. What makes the Earth so special?